Hi, this is Alex from devstories.eu, Python, Cheminformatics, and AI, episode 19 of 22. You evaluate your new generative chemistry model by sampling 1,000 molecules, and the metrics look terrible. You generate 100,000 from that exact same model, and suddenly it looks world-class. Scale changes everything. This phenomenon is called the size trap in generative evaluation. Generative drug discovery pipelines generally follow 3 stages. You train, you generate, and you evaluate. When practitioners reach the evaluation stage, they face a basic question about how many de novo designs to generate for benchmarking. Standard practice often defaults to small batches, typically 1,000 or 10,000 SMILE strings. Teams then run these batches through standard distributional metrics. The most common is Fréchet ChemNet Distance, or FCD. FCD measures how close your generated molecules are to your training set in chemical and biological space. A lower FCD score means your generated distribution closely matches your target distribution. Another common metric is Fréchet Descriptor Distance, or FDD, which compares the distribution of physicochemical properties like molecular weight and topological surface area. Teams also routinely measure uniqueness, which is the fraction of generated designs that are distinct. Here is the key insight. All of these metrics are heavily dependent on the physical size of the generated library. They do not measure absolute model quality in a vacuum. When you sample just 1,000 molecules, your FCD and FDD scores will be artificially high. The model looks like it failed to learn the target distribution. But if you keep sampling from that exact same model, pushing the library size out past 10,000, 50,000, or 100,000 molecules, the FCD score drops significantly. It continues to decrease until it eventually hits a plateau. This happens because generative molecule design involves sampling from a highly complex learned probability distribution. A tiny sample of 1,000 molecules cannot adequately represent the full scope of that model output. The Fréchet distance algorithms need a massive number of samples to accurately capture the shape of the generated space and compare it to the fine-tuning space. Consider a concrete scenario where you're comparing a recurrent neural network against a transformer. If you evaluate the recurrent network using 100,000 designs, but you evaluate the transformer using only 10,000, the recurrent network will likely show vastly superior FCD and FDD scores. The performance gap has nothing to do with the architecture. It is purely an artifact of the sample size. The metrics have not converged for the smaller library. This trap works in reverse when you look at internal diversity. Uniqueness behaves completely differently at scale. At 1,000 molecules, almost every valid SMILE string your model generates might be unique. The model appears highly creative. But as you push the generation toward 100,000, uniqueness drops sharply. The model begins to repeat itself. If you rank different generative models based on uniqueness at a small scale, the differences between them look minor. Push the scale higher and the gap between models widens dramatically. The relative ranking of your models will actually flip depending on the size of the library you use to measure them. To fix this, you must treat library size as a strict control variable in your pipeline. You can never reliably compare FCD, FDD, or uniqueness across libraries of different sizes. To ensure robust assessment, you should evaluate libraries containing at least 100,000 designs so the distributional metrics fully converge. If your evaluation metrics change simply because you let the sample loop run longer, you're measuring the size of the sample, not the intelligence of the model. That's all for this one. Thanks for listening and keep building.